pictures? I mean, you can, but I'm actually going to have a screenshot of all the work. It's going to be on Echo along with the video. So if you want to, that's fine, but there's no reason for it. It'll be on there as soon as school ends today. I'll get it in. Okay. So what we're going to do is we're going to start out with at least one question from every section. I may do two on a couple of them, but hopefully by the end of this, you've got a lot better understanding. So let's just start with question one, because that seems to be what a lot of you are having trouble with. And we may look at another one in this section. One says determine whether each equation represents a direct variation. If it does, find the constant of variation. So, direct variation, what's the equation we talked about yesterday that showed whether or not there's a direct variation? Y equals kx. So our goal in the first section is to make those equations into that equation. So I need to get y by itself. Okay. Once I get y by itself, if there's no plus or minus over here that's added to the kx, then it's a direct variation. If you do have a plus or minus, then it's not a direct variation. Okay. So number one has 3y plus 2 equals 2x. Okay. So if I am trying to get this by itself, what's the first thing I need to do? Yeah. So y'all both have that. Subtract 2, and you're subtracting it from both sides. But on the left side, there's two things to subtract it from. Which thing am I going to subtract it from? I want to get rid of the 2, so I'm going to subtract it from the 2. Because 2 minus 2 is 0, and that's what we're trying to do is eliminate that 2. Okay? So I did that to the left side now. Now I got to go over here to the right side and subtract 2. Okay? Now, I'm going to remind you, as many times as I possibly can, you cannot add and subtract two terms that do not have the same variable. So when I pull this line here down, it's going to be 3y equals 2x minus 2. I cannot combine those two and say it equals x, or it equals 0x. Okay? Because it don't. Yeah. Those are not like terms. I cannot add or subtract them together. Okay. All right, moving on. If I still need to get y by itself, the next step I need to do is get rid of that 3. And to get rid of that, somebody just said, I divide by 3. 3 divided by 3 is 1, so I'm just left with y on the left. Okay, what do I do on the right side? Yeah, you divide the right side by 3, which means you divide every term on the right side by 3. And then these are decimals, so I'm just going to leave them as fractions. Then I don't have to worry about even getting my calculator out. And that's my equation. So, that's the equation. Is it a direct variation?
No.
No. Why not? That little minus sign right there is telling me that it's not a direct variation. So, no. Okay, if that minus 2/3 wasn't out there and it was just that first part, y equals 2/3 x, that would be a direct variation. But because that minus 2/3, it's not. Okay. That one's not. So, because it's not, I don't have to answer the next part of what is the constant of variation, so that's okay. The other 3, 2, 3, and 4, those are all yeses. So you do have to find the constant on each of those. Okay, 2, 3, and 4 are all yeses, so you do got to find the constant. Okay. Questions over this part? They're doing a pretty good job of keeping me going through it. So. Okay. The next section, 5, 6, 7, and 8. On the first 4, if it's no, you just write no. If it's yes, you have to write yes, and then tell me what k is. So like if you ended up with y equals 3x, then you would say yes, and you would say k equals 3. Because that's what's in front of the x. Okay. 5, 6, 7, 8 says suppose y varies directly with x. So this one, it tells us that it is a direct variation. Okay, there's no having to figure that out. It is. It says write a direct variation equation that relates x to x and y. Then find the value of x of y when x is 8. So somebody said number 6. We'll do that one. This one says y equals 15 when x equals 5. Alright, so if I'm going to write a direct variation equation, I have to find out what k is. Okay? And so my equation is y equals kx. So I'm going to take my value for y and put it here, my value for x and put it here, and solve for k. So 15 equals k times 5. Solve for k, what do we get? 3. So I divide both sides by 5. So 3 equals k. It is. Even on, I think number 8 has decimals, but if you use your calculator, it divides out and it's like a 1 decimal answer. So it's the same process. So that's what k equals, but that's not what it asks us to find. It asks us to find the equation, which isn't much more difficult. I'm just going to take 3 and plug it in for k up here. So y equals 3x. That's my equation. Then there's another part to this, and it says find the value of y when x is 8. Y equals 3 times 8, so that's 24. So those are the 2 parts to number 6. Okay. Does that make sense to everybody?
Is that number 9?
That was number 6. We're about to look at numbers 9, 10, and 11 real quick. No, on you talking about where the put the 8. If you look at the problem, it says then find the value of y when x equals 8.
Oh, yeah.
So you'll do that on all 4 of those problems: 5, 6, 7, and 8. Yeah, I've had that question probably all but one of my classes, so you're good. All right. Next piece on 9, 10, and 11. You're just going to draft a quick sketch. I don't want an elaborate graph that you need to go into Desmos to do. I do want a Desmos graph on the research jobs part 1 piece. Do what? To put on the sheet. I tried, but the way the sheet was set up, I couldn't get it to fit on there. So, or I would have. But the graph is very simple to do. Okay, for each one, 9, 10, 11. You're going to draw a y-axis and an x-axis. So you'll just have 3 of them right there. They do not need to be big. You're just going to draw 3 coordinate grids real quick. Okay. The next step you're going to do in all of them is you're going to go to the origin. You're going to put a little dot. Because for it to be a direct variation, 2 things have to happen in a graph. It has to go through the origin, and it has to be a straight line. It cannot be a curve, it can't be a little S, no U's, none of that other stuff. It has to be a straight line through the origin. Okay. Tell me real quick, I'm going to repeat that back to you. What does it have to be a direct variation for the graph? Straight line through the origin. So before we finish questions 9 through 11, I want y'all to turn your paper over to number 20 and answer number 20 really quick. Oh, a sheet. All right, y'all got that one down? All right, now flip back over to 9 through 11. Okay. Everybody remembers this form, right? Okay, for a direct variation, B is 0. We've already talked about that. Okay, so I put the dots in the middle. And then the K is a what? It's the slope. Rise over run. So K is the same thing as M, which is the same thing as rise over run. So Y equals negative X. That was one of the problems. What's my slope? What's my K? What's in front of the X? Negative 1, right? You know, the one's not written. So my slope, negative 1 over 1. So for this, I would go down 1 to the right 1. Put a dot, sketch my line. Said I'm not expecting just an elaborate graph on these three. I just want you to show me that you know where the things go. Okay? Goes to the origin, and then use whatever the K is as your slope, your rise over run. Okay. So that should be pretty clear. I don't think this was number 11 or number 9, so don't put that one on the far left one on your graph. Put it under the one that it's supposed to go under. Questions on the graphs? All right, I'd love to wait and let y'all work all of them out every time, but I want to make sure we get through all the problems, so which we should. All right, number 12. Number 12, a lot of people asked about initially, and when I first read it, I was like, oh, this is kind of confusing. But as I read it again, it's really probably the easiest problem on here. It asks about the perimeter of a square. Okay, y'all, what's perimeter mean? Distance around, right? Okay, what's a square?
All sides are the same.
How many sides?
4.
4. And all sides are equal. Alright, so it says, in this problem it says the length of the side we're going to list as L, and it wants you to write a direct variation equation for the perimeter of a square. Alright, I'm done. Perimeter is 4 times the length of the side. That looks just like a direct variation. Y equals Kx. What's our K? 4. Okay? It does say, it's not completely done because it does tell you to graph it. But your graph, there's your slope, 4 over 1. And you start at the origin again. I will ask one thing though on this one. What does the L represent? The length. Can you have a negative length? No. So when you graph this one, you're going to start at the origin and just go up. You won't have any going down because you can't have a negative length. Okay? So that's the only difference in this graph and the ones we just stepped into. Okay. I didn't. I just put it down. Okay. Number. Okay. Fellas. Turn the page over. Number 14. No. I can understand why you would think that though, because this is what we would have done in the past with this a lot. Let's find the slope. Okay. This one again, you're trying to determine whether or not y varies directly with x. Okay. So I need to know, is this a direct variation? So again, what's my direct variation equation? Y equals kx. Do I know what k is on this problem anyway? No. So I need to find it. You okay? I'm kind of having a little seizure activity back there going on. A little beat in your head.
Yeah.
Nothing. Let's keep it in the head. Yep, I need to find k for each row. And hopefully, well, if k is the same for each row, then it is a direct variation. If even one row is different, then it's not a direct variation. Okay. So, first row. Where y is, I'm going to put negative 6.9 equals k times x, which is 6. Okay. How do I solve for k? Divide 6 on both sides. So k equals negative 1.5. Now that's it for the first line. So now I want the next one to be the same. So I'm going to use this one. Negative 11.5 equals k times 10. Divide both sides by 10. K equals negative 1.5. Those two are the same. Okay, so should we stop there and just put it, say, hey, that's good?
No.
No. You got one more to try here. Negative 8.05 equals k times negative 7. Divide both sides by negative 7, and I'm going to stop right there. Because up here, k was negative both times, right? Down here, negative divided by a negative is a positive. No, it is not a direct variation. Now, if you divided that out, that'd be fine. You still wouldn't get a negative 1.5, but I could stop right there because there was an obvious no in that case. Okay. I can tell you that personally, I wouldn't have done any of this. I would have looked and said, if I put these in order from least to greatest, the negative 7 would be up here. If I put these in order, then the negative 8.5 would be in the middle. I can't flip-flop into two different spots and it still be a direct variation, so there's enough. But for most of us, we're not going to quite get that as easily as just going through the process. The process will work every time. All right. Moving on. 15 and 16. If you go back and look at problems 5, 6, 7, and 8.
Yeah.
15 and 16, you work them out just the same. Okay. There's nothing else you got to do there. You're just going to try to find what k is, I think, for the equation. 15 and 16. Write a direct variation equation that relates x and y, then graph the equation. So you're going to plug y and x in and find k, just like we did on 5, 6, 7, and 8. Or like we did on number 6. Okay, so let's get into the ones where a lot of us had a little bit of trouble. 17, 18, and 19. Brianna, pay attention to 17, because I think I told you wrong last night. Homework upline. Or not homework upline, whatever that thing was. Parent teacher conference. It says, tell whether the two quantities vary directly and explain your reason. Okay. It says, Sarah makes $3.50 more per hour than Pasco. So if I want to know if it's a direct variation, I need to be able to find k. And it needs to be an equation that's a y equals kx. So let's let x be Pasco's pay. His hourly pay, I guess, is better. Okay, x is going to be Pasco's hourly pay. Y is going to be Sarah's hourly pay. So what y'all need to do is write an equation that relates those two things. Okay? Y'all help me out. Somebody give me an idea of what they should do. What? It'll just be one equation because you want to relate the two together. Here, I'll even start it for you. Sarah's pay equals. What does Sarah's pay equal? Alright, so what does more than mean? Yeah, we had trouble with that in a few of my classes. If I've got $5 more than you, and you have $10, how much do I have? 15, because you add those together. So if Sarah's hourly pay is $3.50 more than Pasco's, that's the equation. Right, but we don't need to know how many hours. The way it's read, it's talking about the hourly pay, so we don't need to know the number of hours. Okay. So this is the equation. Is this a direct variation? No. Why is it not? Because I'm adding to the x, not multiplying by. Okay? Questions? Okay, I will tell you that 18 and 19 are both direct variations. So you need to get the equation. Okay? 18 and 19 are both direct variations. Yes, sir.
Okay, if you subtract or add, it is 9.
Correct.
But if you divide, it's still...
Yes, because dividing is the same thing as multiplying, as long as the x is on the top. 18 and 19 are both direct variations. So they'll be yes, so you'll have to give me the equation. What's k? All right, any other questions? Okay, we are down to 3 minutes. This will be due when you come into class tomorrow. So you had last night to kind of get stressed over it. So hopefully you're in a little better spot now. And that's the 3 minutes. T21. I would point at the wall, but it got erased on me. All right.